MS Ramaiah University of Applied Sciences.
Hello friends, with this experiment we are determining the bulking of sand sample. Apparatus: 250 ml measuring cylinder, 6 mm iron rod, porcelain dish, steel rule. Sample: collect about 500 grams of sand from the site. The moisture present in fine aggregate causes increase in its volume. This is known as bulking of sand. The moisture present in the fine aggregate develops a film around the particle of sand, and due to surface tension it pushes apart sand particles, causing an increase in volume over the same amount of sand in surface dry condition. The bulking of sand affects the mix proportion if the mix is designed by volume batching. Bulking results in smaller weight of sand occupying the fixed volume of measuring box, and mix becomes deficient in sand, which causes segregation of concrete, honeycombed concrete, and yield is also reduced. The extent of bulking depends upon the percentage of moisture present in the sand and its fineness. Increase in the moisture content of sand up to a value of 5 to 8% causes bulking ranging from 20 to 40% as shown in figure. As the moisture content increases, the film of water formed around the particle merges and water moves into voids between particles so that total volume of sand decreases till the sand is fully saturated. The volume of sand at this stage is same as that of dry sand. Procedure: percentage of bulking sand. 250 ml measuring cylinder is taken and damp sand is poured into it up to 200 ml mark. Sand is consolidated by shaking. Then cylinder is filled with water sufficient to submerge the sand completely, and then sand is stirred well. Now the volume occupied by sand is noted down, that is YML. Calculations and observations in terms of original volume of sand, volume of sand surface after immersing in water, percentage of bulking sand over dry sand is calculated.
Hi students, as a part of Concrete and Highway Laboratory, now we are doing an experiment called as bulking of sand. The apparatus required for the bulking of sand is, we want the fine aggregate to be tested, we want the measuring jar 1 liter, 500 ml as well as a 100 ml measuring jar, and we want a weigh balance. All of you know that the increase in the moisture content increases the volume of the sand. If the particle size of sand is more, that means the water required for creating a film around the particle will be higher, okay, and your bulking will be lower. Whenever the particle of sand will be more finer, what happens? The bulking will be more, the volume expansion will be more. That's why we are supposed to determine the bulking of sand. What we are going to do is, let's start the experiment. We are going to take up the fine aggregate. I am going to place it in a 1 liter cylinder for a known height. What I am going to do, I am going to place it for 1000. I am going to place completely 1 liter on this. So now what I did, I just placed completely the sand up to 1000 reading. Okay, what I am going to do for security reasons or for some reasons, I am going to measure the height of it. It is 30.5. So I am keep on adding every percent of water into it, and I am going to keep on measuring the height. So 1% of 1000 is 10 ml. I am going to add 10 ml of water. What I'm going to do? I'm going to measure the height. Same, no change. So what I'm going to do? I'm going to keep on doing the number of trials with each increased percentage in water. What happens when I keep on adding this water? Okay, some particular value, your stand starts expanding. There's an increase in a volume, and you are going to observe a height in the reading. Similarly, after repeating number of trials, what happens? There will be increase in a value. Further addition of excess water will decreases the reading. You plot the graph of height versus the percentage water added. From the graph, you are going to get optimum bulking as well as the optimum water content for that particular bulking. This completes the bulking of sand experiment.
At MSR UAS, we spark your imagination unlike any other.